So I think that for everybody it's pretty clear what's at the base of an ELISA kit. We have a binder, we have a ligand, and then we can have the binding reaction between the two of them. Such binding reaction might be influenced from external features. For instance, we are talking about environmental conditions like high temperatures, low temperatures, or some errors regarding liquids or reagents, for instance, some mistakes in pipetting. And so actually the question would be what actually could help us in ensuring, in being confident that what we are observing on the reader is something true, something reliable, rather than something that is influenced. Well, the answer is pretty simple, and it's calibration. Calibration is, of course, very useful, but also it comes with some, let's say, side effects, some unpleasant features, like an increase in your assay time, because actually, of course, you have to pipette also the standards other than your samples. And you have an increase in your cost of analysis, because, again, you have to use some of the wells for the standards instead than for your samples. And finally, since you're performing more steps, you have an increase in the error probability. So it is our opinion that a next generation ELISA kit should be able to guarantee the same results of current ELISA kits, or even better if possible, but maybe avoiding the need of calibration. So, how can be this achieved? Well, it's pretty easy. Actually, if you consider classic ELISA kits, well, the kit is manufactured by a producer, then it is used to analyze a sample, and then finally what you get is something similar to this plate. You have your calibration curve with some wells, and then you have the samples that are the other wells. In the so-called next generation ELISA kits, what you get is still a normal production, but at this step, a master curve is introduced. And what is a master curve? Simply is a standard curve, a calibration curve, which is lot specific. In this way, once you use to analyze your sample this kind of kit, what you physically get is this kind of plate, where you see just one standard is physically used. All the other, just one well is used for the standard. All the other wells can be used for the samples. However, you still have a master curve, so you can be reliable on these kits. So, making a comparison between classic ELISA kits versus these next generation ELISA kits, we can see that classic ELISA assay used to have maybe a lot of standards, 7 standards sometimes, and a duplicate layout. So, if you consider that an analysis of 3 samples, overall the consumption will be of 20 wells, quite a lot. In more recent fast ELISA assays, the number of standards was decreased, and also the layout was kind of decreased to single. So, to analyze 3 samples, you would use just 8 wells. But the further increase is new generation assays with single layout, and as we've seen, just with one standard. So for the analysis of 3 samples, you use 4 wells. If you make the comparison on the whole plate kit, the advantage is even more clear. I mean, considering analytical sessions of 3 samples, you see that with the classic ELISA assays, you would analyze 12 samples. With fast ELISA assays, 36. With the next generation analysis, 72, with a 96 kit. And therefore, the cost effectiveness is immediately cheaper. So, what is the state of the art? I mean, we're not talking about something hypothetical, something theoretical, but something existing. So, there are many kit producers around the world that are capable of producing ELISA kits, classic ELISA kits. Some of them specialized and managed to adopt fast ELISA assays, and a group of them even made even better because we adopted these kind of single standards ELISA kits. Our approach is a little bit further because we also adopted a single sample preparation based on methanol, so you can perform the extraction just once, and then you can run in parallel all these kits. All of this is possible thanks to the B0 kit, which is our dedicated line to mycotoxins, and here we will see just a brief summary. We have the B0 kit for aflatoxin B1, which is specific for this mycotoxin, and as you can see, it can be adapted on different matrices. It has a detection range that goes from 1 to 40 ppb, and the detection time is just 15 minutes. Then we have also the same version of the kit for total aflatoxins. As you can see, it's applicable almost on the same matrices. The detection range goes from 2 to 80 ppb, and the assay time is still 15 minutes. For the oxynivalenol, we can apply this kit to cereals, feed, and GS. We have here two different detection ranges because for cereals in general, we have the 40 to 5,000 ppb detection range, and for durum wheat, we have the 120 to 15,000 ppb. The assay time in this case is 20 minutes. And finally, we have the B0 kit for zearalenol, which is still applicable to the same matrices, has a 25 to 2,000 ppb detection range, and is still on 15 minutes assay time. However, this is not all, because actually Tecna has quite a sound experience in producing ELISA kits for aflatoxin M1. And so we developed the B0 kit for aflatoxin M1 500, specific for the countries that follow codex regulation. And so we can apply this kit to raw milk and milk powder with a detection range respectively of 25 and 500 ppt and 50 and 1000 ppt. Obviously it's specific for aflatoxin M1, and again the assay time is just 20 minutes. But most important of all, sorry, the sample preparation. Actually there is not sample preparation because you do not have to skim this milk, you do not have to centrifuge, to cold it, you just have to pipette it in the ELISA. So, in conclusion, the key features of our B0 ELISA kits are very simple. Reagent stability provides an incredible robustness for our B0 kits. In this way, we can minimize all the, let's say, side effects of calibration, which, as I said before, are time, money, and error probability. And this takes to a whole new level of testing. So, thank you very much for your attention. And we are